Physics allows us to see a realm of wonders. It enables us to visualize and predict the outcomes of certain actions. For instance, this stunt ride shows how physics equips the mind with the right devices to calibrate actions and decisions accordingly and with all conditions considered to arrive at the desired outcome. The following lesson on projectile motion best exemplifies this. Let us now explore how the interplay of its variables makes this possible. Before we continue, let us review some words you have met already in your study of projectiles in junior high school. What do we call the object that has an initial velocity following a projectile motion? That's correct. This projectile is entirely influenced by acceleration due to gravity and a resistance as it follows a parabolic path that we called. Nice. It seems that you still remember these vital concepts. But for the entirety of this discussion, we will be treating projectiles simply as particles or objects with, first, constant direction and magnitude, and second, affected only by gravitational acceleration, disregarding other factors like air resistance and the Earth's rotation and curvature. We understand in the previous discussion that gravitational acceleration is entirely vertical. For this reason, projectile motion is limited to a vertical plane, is strictly identified by the initial direction of the initial velocity, which is in horizontal path. Therefore, we can visualize a projectile using this xy coordinate plane, comprising with both x and y axes. Say I launch a projectile, it heads in the vertical plane with an initial velocity vector v sub 0. Then, it will continue to move in a parabolic path, our trajectory, which is solely influenced by the gravitational acceleration. Let us have another visualization. Suppose we throw a yellow ball horizontally from a given height. Let us compare its motion against another object, which is a red ball, in a free fall. This yellow ball's initial velocity is considered to be its initial and final velocity, since the velocity remains unchanged. Given that the velocity remains unchanged, what can we say about its acceleration? Correct. Acceleration is zero, since there is no change in both magnitude and direction. We can notice from this illustration that both yellow and red balls are recorded at equal time interval. Moreover, for both of the balls, the acceleration in the y component is constant and is equivalent to negative 9.8 meters per second square. This shows that the horizontal and vertical components of a projectile are independent with one another, and therefore each component doesn't affect the other. Considering these situations, what can we say about the projectile motion? We can tabulate the information to summarize the key concepts that we need to remember in dealing with projectiles. First, it has two components, horizontal and vertical, each independent with one another. The horizontal component is initial velocity, which is constant throughout the motion. And since it is constant, the acceleration in horizontal component is zero. Next, in y component, the velocity decreases as it goes upward and increases as the object falls down. It also has a constant acceleration of negative 9.8 meters per second square, which is our gravitational acceleration. In the next video, we will talk about how are these projectiles computed and what are the variables that interplay in these exciting concepts of physics. This is Gilmar Di Castro, and see you in the next video.